Hey, what is up, everybody? Welcome. Let's jump right into it with task 1. So this is Linux Fundamentals Part 3, basically the final part of the fundamentals path. At this point, we're moving away from the super basic stuff and more into things you'll actually use all the time, working with files, processes, packages, automation, real day-to-day Linux. Although I've said this in every previous Linux room so far, I feel like I'm starting to lose my credibility. So the goal here isn't one big concept. It's stacking practical skills on top of what you already know. And you know a lot, because you were doing this room with me. Let's go ahead and deploy the machine and jump in. Okay, I will stop using the word jump from now on.
Task number 2.
Alright, so before we do anything useful in this room, we need the machine up. Go ahead and hit the Start Machine button for the target first. And then after that, you also want the attack box running, because that's the box we're going to be working from while talking to the deployed Linux machine over SSH. So there are kind of two sides to this setup here. One machine is the target we're connecting into, and the other one is basically our workspace. Once the target starts, scroll up and grab the IP address that gets assigned to it. That matters because that's what we're using to log in. And yeah, this is one of those tiny things that's easy to gloss over, and then 2 minutes later, you're wondering why nothing is connecting. So just make a mental note of it now, or write it down somewhere if you want to avoid annoying yourself in a second. For the credentials here, the username is TryHackMe, and the password is also TryHackMe, which is nice because at least we're not fighting the login before we even start. And really, that's the main point of this task. Just get the environment ready and make sure you understand which machine is which. Once both machines are up and you've got the IP, we're good. Then we can move on and actually start doing things inside the terminal. So let's connect with the given credentials to the machine. Copy the IP address, paste it, accept, try hack me password, and we are in. Task 3. Now we get into terminal text editors. And this is one of those things that starts out feeling kind of unnecessary until you stop wanting to build files one echo at a time. Because up to now, we've mostly been writing to files in the clunky way, right? Using echo, then greater than or double greater than. And that works, technically, but the second you need to deal with multiple lines or actually edit something properly, it gets old really fast. So this task introduces nano, which is the more beginner-friendly editor, and then it briefly mentions Vim as well. So for nano, the usage is really simple. You just type nano, followed by the file name you want to create or edit. So if I do nano my file, that opens the editor and drops me straight into it. At that point, you can just start typing. No weird mode switching, no fighting the editor, just type the text you want into the file. And that's why nano is usually the one people start with. It's just easier. You'll also notice at the bottom of the screen, it shows you the shortcuts, which is honestly very nice because you don't have to memorize everything immediately. So when you're done, the big one is Ctrl+X to exit. If you change the file, nano will ask if you want to save it, and then you confirm. That part trips people up the first time because they hit exit and then kind of panic when another prompt appears. But it's fine. It's just asking whether to write the changes. So for the room itself, first you just need to create a file using nano, which is basically there to get you comfortable opening it. Then after that, you need to edit the file called task3 in the TryHackMe user's home directory and pull the flag out of it. Now, one little thing here, and this is usually where people make the annoying mistake. Make sure you're opening the correct file in the correct location, because if you type the wrong path or the wrong file name, nano will happily open a blank new file, and you might think, wait, where's the content? And yeah, the answer is usually that you accidentally created a new file instead of editing the existing one. Let me just demonstrate it quickly so you understand what I'm talking about. If I mistype the file I want to open with nano, like nano task33, then, as you can see, it simply creates it and opens it. You won't understand where your flag is because you don't notice that you gave the wrong name or the wrong path. Let's exit from here with Ctrl+X, choose No, and check the flag with nano task3. copy it out, and task 3 is complete. So if the file is in the home directory for TryHackMe, just be mindful of where you are when you launch it. If you're already in that home directory, great, Nano task 3 is enough. If not, use the proper path and open it directly. Then just read what's in there and grab the flag. The task also mentions Vim, but only kind of in passing. Vim is more advanced, much more customizable, and a lot of people love it for code and heavy terminal work. But this room isn't expecting you to suddenly become a Vim person in 5 minutes. So really, Nano is the one that matters here. So yeah, the takeaway from this task is pretty straightforward. Stop brute forcing text files with Echo, start using a real terminal editor, and for now, Nano is more than enough. After that, we can move into some actually useful utilities for transferring and serving files. With that said, let's check out task 4. This task is basically a small collection of utilities that you end up using all the time in Linux, especially once you start moving files around between machines or need a quick way to host something. And the 3 main things here are wget, scp, and Python's built-in HTTP server. In short, we'll cover how to transfer files between 2 Linux machines and how to download files from the internet. Everything done directly from the Linux terminal. wget. wget is just a really easy way to download files from the web straight into your terminal. If you know the URL of the file, you can pull it down without opening a browser, without clicking around, nothing fancy. You just run wget followed by the address of the file you want. So if there's a text file or script sitting somewhere online, wget will grab it for you and save it locally. Pretty straightforward. So there you can see an example there. If I could copy it, it would download this myfile.txt, but these boxes aren't connected to the internet, so we can't do it there. And this is one of those commands that sounds basic, which it is, but you will use it constantly. Scripts, tools, payloads, word lists, random config files, whatever. It comes up all the time. Then we've got SCP, which is secure copy. This one works over SSH. So instead of downloading from a web server, you're copying files directly between systems in a secure way. And the only thing you really want to keep straight with SCP is the source and the destination, because that's where people usually trip over themselves. You're either copying from your machine to the remote machine, or from the remote machine back to your machine. Same idea both ways, just reversed. So in a nutshell, we use SSH to copy a file from A to B machine and vice versa. So if the file starts on your local system, local is the source, and the remote path is the destination. If the file starts on the remote box, then the remote path becomes the source, and your local file name becomes the destination. That's really the whole mental model. And yeah, this is one of those commands where if you reverse the order by accident, you don't get what you wanted. Best case, it just fails. Worst case, you copy the wrong thing to the wrong place, and now you're cleaning that up for no reason. Let me just demonstrate it to you. I opened another terminal. This is my attack box terminal. Remember, we connected with SSH to the virtual machine, which is the top terminal called Linux 3. Let's check out the command we would use. First, scp, the command itself, then the name of the file we want to move from our machine, then the name of the machine we are sending it to, this one, and after that, we define the path where we want to move the file, along with the name we want it to have. Once again, so you don't get confused, and I know it can be hard to understand at first. So, in the first command, you're basically sending a file from your own machine to a remote system. You take important.txt locally, and you push it over to the target, at which is their Linux 3, saving it as transferred.txt in the /home/ubuntu/ directory. In the second command, you're doing the exact opposite. You're connecting to that same remote machine, grabbing the file documents.txt from /home/ubuntu/ and pulling it down to your local machine where it gets saved as notes.txt. A really easy way to think about this is just to look at where the user @IP: part is. If it shows up at the end, you're uploading from local to remote. And if it's at the beginning, you're downloading from remote to local. Now, the third part here is probably the most fun one in the task, which is using Python 3's HTTP server module. This is super handy because it lets you turn your current directory into a quick web server with basically one command: Python 3-m, which stands for module, HTTP server. That's it. Run that in a directory, and the files in that directory are now being served over HTTP, by default on port 8000. So please read through all this, and we're going to head to the questions, and it will make it easier to understand what I'm talking about. Yeah, let's just check out these. So the room wants you to start that server in the home directory of the TryHackMe user on the deployed instance. That part matters because the server will serve whatever directory you launch it from. So if you start it in the wrong place, the file you want won't be available even though the server itself is technically running fine. That's a very normal mistake, by the way. The command works, but the file isn't there, and now it looks like the room is broken when really you just launched the server from the wrong directory. So the task says that we need to be in the home directory, so let's just use the command we learned earlier, pwd. And as you can see, we're in the home directory, so we can host our web server from here. So let's type in our command, which is python 3-m, don't forget the switch, http.server. At this point, the web server is running on this machine, in this directory. Let me just rearrange a few terminals so it's not such an awkward experience to watch the screen. All right, so now from a second terminal, and this is important, a second terminal, you use wget to download flag.txt onto the attack box. You can't really do both things in the same active terminal session because the Python server takes over that terminal while it's running. So if you try to keep using that same session, you're going to have a bad time, or just a confusing one. All right, so let's just copy this command, and let's talk a little. You are a fucking genius, so you noticed something. Hey Adam, why is the IP address different in the command than in the hosted HTTP server? Well, that's a really good question, my dear besto friendo. But, sadly, I am not going to explain it because it is out of the scope of this room. If you are really eager to get this irreplaceable knowledge, Google it. Also notice the port there, 8000. That needs to be included in the URL because the Python server is not serving on the normal web port. If you leave the port out, you're asking for the wrong service and the download won't work. Same thing with the file name. You need the exact path, in this case, .flag.txt, not just the IP and not just the directory. The basic Python server doesn't give you some polished indexed browsing experience unless you already know what's there and where it is, so the exact file path matters. So the flow for this task is really start the Python web server in the right directory on the target, open a new terminal, use wget from the attack box to pull down .flag.txt, so just press enter there, read the contents, and that gives you the answer. This is the answer. Then when you're done, go back and stop the Python server with Control+C. All right, let me just copy this to answer, paste it, and we are done with task 4. So let me just close this and this, or do I close this one too? Whatever, I'll just close it. Let's go ahead with task 5. All right, now we're talking about processes. And this is one of those topics that sounds more intimidating than it actually is at first. A process is basically just a running program on your machine. So if something is currently executing, whether that's a shell, a script, a service, whatever, it exists as a process. And every process gets assigned a PID, which is just its process ID. That number is how the system keeps track of it. So if one process had an ID of 300, the next one that starts would get 301. Nice and simple there. To actually look at processes, the room starts with PS. And this is also the moment when I regret closing the SSH terminal, because I have to reconnect now. Sag. So, SSH TryHackMe at IP. Yes. TryHackMe again. And use PS. If you just run PS, you get a snapshot of the processes tied to your current session. So it's a pretty limited view, but it's a clean one. If you want the bigger picture, including processes from other users and system processes, then you go with PSAux. That one is a lot more useful when you're trying to actually see what's going on across the machine. So probably you will use mostly PSAux if you want to look into processes. Let's clear this up so we don't get lost. So our next command is top, which is kind of the live version of this idea. Instead of a one-time list, top gives you a real-time updating view of processes. CPU usage, memory usage, all of that. So, yeah, if PS is like taking a screenshot, top is more like watching the system breathe in real time. That's a weird way to say it, but you get the idea, right, my little possum? To get out of the top command, just use Control-C. Now, once you can see processes, the next thing is controlling them. That's where we use the kill command. You use kill followed by a PID to send a signal to that process. And the important detail here is that kill doesn't always mean just instantly nuke it. It means send a signal, and depending on the signal, the process reacts differently. So yeah, the room calls out 3 signals in particular. SIGTERM is the clean one. This is the one you use when you want the process to shut down properly and clean up after itself first. So if the question asks how to cleanly kill a process, this is the answer, not SIGKILL. That's the one people mix up all the time. SIGKILL is the hard stop. No cleanup, no graceful exit, just done. Then SIGSTOP suspends a process rather than ending it. And yeah, that distinction matters because sometimes you don't want to smash the process immediately. You want to let it close files, release resources, do whatever shutdown work it needs to do. The task also drifts a little into how processes start, and this is where systemd is important. You don't need to go super deep here, but the idea is that when the system boots, one of the earliest processes that gets started is systemd, and other services and programs can start under that. So it kind of sits there managing things. We could call it like a parent process to everything on the machine. So if we check out our processes with PSAUX, then we can see, SBIN/init, but in a nutshell, it is the same, because it is a modern lab. Let's see the next one, systemctl. Systemctl becomes the command we use to interact with services. And the syntax for systemctl is pretty easy to work with. It's just systemctl followed by an action and then the service name. So if I want to stop a service called myService, I'd use systemctl stop myService command. If I want to make that service start automatically when the machine boots, I'd use systemctl enable myService. Those are 2 separate ideas, by the way. Stop affects it now, enable affects startup behavior later. That's another one people blur together a lot in the beginning. So as you can see in the material, we use the command systemctl, then the option, like start, and the service we want to start, Apache. You can also see it there. There you can see the 4 options you can use with systemctl, as we just talked about it. Yeah, I'm challenged. There are 5 options. Let me just go through them really fast, so you won't be frame-mogged by TryHackMe as me. Alright, so when it comes to managing services with systemd using systemctl, there are 5 core options, and they're actually pretty simple once you map them to real actions. So first, start just means you're turning the service on right now. It runs immediately, but nothing else changes. Then stop is the opposite. You're shutting the service down right now. Now enable is a bit different. This doesn't start the service instantly. Instead, it tells the system, hey, every time this machine boots, start this automatically. And disable is just removing that behavior. The service won't start on boot anymore, but if it's currently running, it keeps running until you stop it. Finally, status is just for checking. It shows you whether the service is running, stopped, or if something went wrong. So the quick mental model is, start and stop is right now, enable and disable is on boot, and status is just checking what's going on. Now the last part of the task is backgrounding and foregrounding, which is really useful once you start running commands that you don't want taking over your whole terminal. You can read through all this, but I will just explain it to you briefly. Normally, when you run a command, it runs in the foreground. Your terminal is focused on it, and that's basically all you're doing until it finishes. But if you add "and" to the end of a command, it runs in the background instead. So the terminal gives you the process info and hands control back to you. That's nice when you want something to keep running while you continue working. You can also suspend a running foreground process with Control-Z, which kind of pushes it out of the way. It's not dead, it's just paused and backgrounded. That's an important difference. People sometimes see it disappear from the terminal and assume it's gone, but no, it's still there. It's just stopped for the moment. Then, if you want to bring that backgrounded process back into focus, you use FG. That's the command the room is looking for there. FG brings the process back to the foreground so you can interact with it again. Simple, but extremely useful once you start juggling multiple things in one shell session. So if you remember, we used the top command before, and it showed us the live happenings. But now, if we use it as top and, then we get the process ID, which is this one, and the number 1, which is its job ID. So if I use the jobs command, we can see our top command as it is stopped. Basically, just type in the jobs command whenever you want to check what processes are running in the background by you, or use PSAUX. The difference between the two is that jobs shows what belongs to the current shell session, and typically what I started in this terminal with Control-Z or with AND. PSAUX lists all running processes on the entire system, as we discussed earlier. So really, the flow of this task is, understand what a process is, recognize that PIDs identify them, use PS and top to inspect them, use kill signals to control them, use systemctl for services, and know how to background and restore processes with AND, Control-Z, and FG. That's a lot in one task, honestly, but it's all stuff you will keep seeing over and over again in Linux. And once this starts clicking, Linux feels a lot less like random commands and a lot more like a system you can actually reason about. Alright, we talked a lot. Let's check out the questions. Feel free to pause here and try the questions on your own first. Then come back and check my answers with the explanations if you get stuck or just want to compare your approach. A few of these are basically straight from the explanation, and then one of them actually wants us to go onto the deployed machine and find the process that's running there. So the first one asks, if we were to launch a process where the previous ID was 300, what would the ID of this new process be? That one is straightforward. The room tells us that process IDs increment in order, so if the previous one was 300, the next one is going to be 301. So that answer is 301. Then the next question is, if we wanted to cleanly kill a process, what signal would we send it? And this is where you don't want to rush, because a lot of people immediately think sigkill, but that's not the clean one. The room says the clean signal is sigterm, because that lets the process do cleanup tasks before it exits. So the answer here is sigterm. After that, we get the flag question. Locate the process that is running on the deployed instance. What flag is given? So for this one, we actually need to check the running processes on the target machine. The easiest way to do that is with PSAUX. And the reason we use PSAUX instead of just plain PS is because plain PS gives you a much smaller view, mostly tied to your current session, whereas PSAUX gives you the broader process list. So once you run that, just look through the output for the process the room has left running and grab the flag from it. So this is the flag. Let's just copy-paste it. Also, sorry if I pronounce PSAUX differently sometimes. To be honest, I have no idea how to say it properly. Then the next question asks, what command would we use to stop the service my service. That comes straight from the systemctl syntax in the task. If we want to stop a service, it's systemctl stop my service. So that is the exact answer for that one. Then right after that, what command would we use to start the same service on the boot up of the system? This one is about enabling it on startup, not just starting it right now. So the command is systemctl enable my service. And yeah, this is one of those little Linux distinctions that matters. So start means do it now. Enable means make it come up automatically on boot. So the answer is systemctl enable my service. And then the last one says, what command would we use to bring a previously backgrounded process back to the foreground? That command is just fg. Very short command, just like your whatever. So if you background something with and, or suspend it with Control+Z, then fg brings it back into focus in the terminal. All right, let's fly to task number 6, where we're moving into automation, which is one of the first places where Linux starts feeling really powerful. I think I say something like this at every Linux task. Much credibility, very honest, so trustworthy. Up to this point, most of what we've done has been manual. Run a command, check the output, move on. But a lot of the time, especially on real systems, you want something to happen on its own at a specific time or on a repeating schedule. Backups are a good example, or launching scripts, or running maintenance jobs in the background without you having to remember to do it every single time. That's where you can use cron. So cron is the service that handles scheduled tasks, and the way we interact with it is through something called a cron tab. A cron tab is basically just a file with a specific format that cron knows how to read. Each line tells the system when to run something and what command to run. So it's not complicated conceptually, but the formatting can look a little weird the first time you see it. The room breaks that format into 6 pieces: minute, hour, day of month, day of week, and then the command itself. So 5 time-related fields, then the actual thing you want executed. That's the whole structure. And this is where people usually slow down a bit, because reading a cron tab line is kind of like reading a tiny encoded schedule. For example, the room gives this example there. And what that means is, at minute 0, every 12 hours, run that copy command to back up the documents directory. Once you see how the fields line up, it starts making a lot more sense. -R means recursively. The asterisk character is also a big part of this. That's the wildcard, and it basically means I don't care for that field. So if you put asterisk in the month field, you're saying it can run regardless of the month. Same for day, same for weekday, whatever. It's just a way of saying this part of the schedule isn't restricted. And honestly, this is one of those places where beginners usually make the same mistake. They look at a cron line and try to read it left to right too fast, without first mapping each field to what it stands for. Then suddenly, */12 is in the wrong mental box, and the whole thing gets interpreted incorrectly. So the easiest way to handle cron is to slow down and decode each field one at a time. Minute first, then hour, then the rest. Don't try to freestyle it. That usually goes badly. So yeah, you can see a lot of asterisk. So it means just do it every 12 hours. We don't care the day of the month, etc. You can also see this link here, so there you can actually just write in what you want to do. Like, I want to run my command every 3 months on Wednesday, and it will just generate the command for it. Now, if you actually want to edit your own cron tab, the command is crontab-e. That opens the cron tab in an editor, usually something like Nano, and lets you add or modify scheduled jobs. So that's the command you'd use when you want to create automation for your user. I would also tell you about crontab-l. It is the same as crontab-e, but instead of editing it, it just lists out the current scheduled tasks you have. So yeah, the main takeaway here is cron handles scheduled jobs. Crontab is the format and the file you edit. The wildcard means any, and if a cron line looks confusing, just decode it field by field instead of trying to guess it in one shot. All right, now for this question. When will the cron tab on the deployed instance run? So for this one, we need to actually check the cron tab on the target machine and read the schedule properly. So as I told you, the command for that is cron-tab-L. And we can see the answer here is reboot. Go ahead and open task 7. All right, now we're getting into package management, which is one of those Linux things you end up relying on constantly, even if you don't think about it that much at first. Because sooner or later, you're going to want to install software. Maybe it's a text editor, maybe it's a tool, maybe it's some utility you need for a project. And on Ubuntu-based systems, that usually means dealing with apt. But before that really makes sense, you kind of need the bigger picture, which is repositories. So a repository is basically a source that your system can use to find software packages. When developers want their software distributed through the package manager, it gets made available through a repo, and your machine can then check that repo, pull package information from it, and install what you need. That's why package management in Linux feels a lot cleaner than manually downloading random installers all the time. The system actually knows where the software is coming from and how to keep track of it. Now, Ubuntu maintains its own repositories, but you can also add third-party or community repositories if the software you want isn't in the defaults. That's the direction this task goes in with the Sublime Text example. It's not really about Sublime specifically, it's about understanding the workflow of trusting a source, adding it, updating your package lists, and then installing from it. I know it can be a lot at first, but let me recap it for you. Linux doesn't really do the whole go to a random website, download an installer, click next 5 times kind of thing. Instead, it uses repositories, which are basically trusted software sources your system knows how to talk to. So the flow is usually very simple. First, you tell the system where the software lives by adding the repository. Then you refresh the package list with apt update so your machine actually knows what's available there. And after that, you install what you want with apt install. And that's really it. No random setup wizards, no hunting around for download buttons, no weird manual installer process. The package manager handles the install for you, and later on it can help keep that software updated too. And the command doing most of the heavy lifting here is apt. Apt is the package management tool, and the common pattern is usually something like apt update, followed by apt install, and then the package name. That order matters, by the way. A lot. Because apt update refreshes your system's idea of what packages are available from the configured repositories. If you skip that after adding a new repo, your machine may not even know the package exists yet, which is a very easy way to confuse yourself for no real reason. So the room walks through adding a third-party repository manually. First, it grabs the GPG key. That key is basically there to help verify trust. Kind of the developer's way of saying, yeah, this package source is really ours. You don't need to go deep into the cryptography here. The practical point is just that Linux doesn't want to blindly trust random software sources without some kind of verification step. After that, the repository gets added into etc app sources list as its own .list file, which is actually a nice habit because it keeps third-party sources organized instead of dumping everything into one giant place. Then once that file exists, you run apt update, and only after that do you install the package with apt install Sublime Text. That's the flow. And yeah, if you read through that and thought, okay, so the repo is not the software itself, it's the place the software is being offered from. Exactly. That's a distinction beginners sometimes blur together. The package is what you install. The repository is where apt learns about it. The room also points out that removing software is basically the reverse process. You can remove the repository, and you can remove the installed package. So package management isn't just about adding things. It's also about keeping the system clean when you don't need something anymore. So the main takeaway here is, repositories tell your system where software lives. Apt is how you manage packages from those repositories. Trust matters, so GPG keys show up in the process. And if you add a new source, you usually need apt update before apt install makes sense. That's really the piece to hold on to. All right, task 8. Now we're looking at logs. And this is one of the most practical parts of Linux once you stop thinking of the system as just commands and start thinking of it as something you may need to troubleshoot or investigate. because systems are constantly recording what's happening. Services log activity, the operating system logs events, authentication attempts get logged, web servers log requests. There's a lot there. And on Linux, a lot of that lives under /var/log. So when something weird is happening, or you just want to understand what happened on the box, this is one of the first places you end up checking. All right, so let's do that, but I think we won't have permissions to do it on this machine. But let's try. So we cd with giving the absolute path to var/log. Check Apache 2. Oh, okay, it's a directory. I'm bad as flock. So cd to Apache 2, and let's check what's inside of it. All right, let's try to open this. Oh, well, yeah, we don't have permissions, but feel free to mess around and try to open logs. The room briefly recaps that, and then points out that Linux is generally pretty good about rotating logs automatically. So older logs don't just grow forever until the machine hates you. They get managed over time, which is useful, but for this task, the important part is really just knowing where to look and what kind of information the logs can give you. The examples they mention include things like Apache 2 logs, fail2 ban logs, and UFW logs. And that's a nice mix because it shows how logs can reflect completely different parts of the system. A web server log tells you who requested what. A fail2 ban log can show brute force related activity. A firewall log tells you about blocked or allowed traffic depending on configuration. So logs are not just one thing. They're really a bunch of different records from different services all living in predictable places. For this room, though, the main focus is Apache 2. Specifically, you're being asked to look at the Apache logs on the deployed Linux machine and identify the IP address of the user who visited the site, and then also identify which file they accessed. So this is basically a very small log analysis task. And the thing you want here is usually the access log, not the error log. That distinction matters. The access log records incoming requests, who connected, what they asked for, when they asked it, things like that. The error log is more for server-side problems, broken configs, failed scripts, missing permissions, that sort of thing. So if the question is asking who visited the site and what file they requested, you're almost definitely looking in the access log first. And lucky for us, I was bad enough to check the wrong access log file while I was fooling around with the log files, so we can be pretty sure that it is in the access log 1 file. That's a very normal beginner mix-up, by the way. People see multiple log files in the same directory and just start opening them randomly. Which, honestly, fair enough. But here the smart move is to think about the kind of answer you need, and then pick the log that would actually contain that type of event. So once you open the Apache access log, what you're looking for is a request line. And as you can see, there's the request line. Let's copy the IP address, paste it, and it's done. Typically, you'll see the client IP address in the log entry, and then somewhere in that same line, you'll see the requested resource, the file or path that was accessed. So the task is really just extracting those two pieces of information cleanly. Don't overcomplicate it. You're not doing full forensic analysis here. You're just reading a web request from the log. Task 9. All right, so that's the room. Quick recap. We went through text editors, file handling, processes, automation with cron, package management, and logs. Basically, all the day-to-day stuff you'll keep using in Linux. Go ahead and terminate the machine, and that's Linux Fundamentals Part 3 done. Please like and subscribe if this video helped you. It means a lot. See you in the next one, Perry the Platypus.